to look at the quality issue of machine translation, because there is a lot of misunderstanding in the general community of machine translation users, and especially among enterprise buyers. And hopefully at the end of the session you will have a little better idea on what matters and how to interpret some of the information that you see. So we'll go right straight into it. So today what we see happening in the world is that MT is used really very, very heavily all over the world. It's estimated that as much as 1 trillion words a day are going through machine translation engines all across many different portals that make MT available, Google being the largest one. But there are many in China and other countries that also process hundreds of millions of words a day, if not billions. Alibaba alone uses as many as 200 billion words a day, translates as many as 200 billion words a day. So we're in a point of time where there's a huge amount of machine translation happening. The localization part of the whole use of this technology is really very, very small. It's probably a fraction of 1%. And so localization is a small user. They're a very specific kind of user. And most of what machine translation being used today is for other things. This 99% that we're looking at here also includes a lot of enterprise users. People are translating emails, PowerPoint presentations, PDF documents of product plans, of communications with foreign customers, of things that really shouldn't be going into public domain machine translation engines, because a lot of the big machine translation facilities, capabilities that are offered for free, are using your data to teach their engines to basically prime their machine learning engines. And so there is risk of exposing important data there. But the fact is that the need is huge. We estimate that the rogue enterprise use is in the range of 5 to 10 times the localization industry. So yesterday there was a panel here, and there was a gentleman from Texas Instruments who told us that their IT measured the amount of data being used in Google Translate and other open MT engines, and they were saying on average it was 3 gigabytes of data a day going through public engines with critical information about customer situations and business plans, new product development, these kinds of things going through these engines, which put a lot of risk to the company. So if there is a need for large-scale machine translation within many global enterprises, there is a need for enterprise buyers to understand what's the best MT technology solution out there, and is it good enough to use for some specific applications that they want to use it for. And these questions today, they're complicated to answer because there's no straightforward answer and there's no clear way. One thing that everybody uses today is either these automated metrics, like Blue is the one that's most popular, but there is a one currently very popular called LIPOR. And there are third-party agencies that measure MT systems side by side with some kind of data and produce a score, which may or may not be meaningful. In many cases, not that meaningful. The best way still is to have humans assess machine translation output, to assess the linguistic quality. But that's really all they can do. They can assess linguistic quality. Using human beings is slow, costly, expensive, and also inconsistent, because some people grade very hard, some people grade very easily. And so how do you normalize for that? So there is a challenge for the enterprise buyer on what to do. it's worth taking a few moments just to talk about the Blue score, because this is something you'll hear about all the time. It's the most widely used automatic metric, associated often with quality, but not really truly a quality measure. It's a quick and dirty way for the guy who's building the MT engine, for the developer, for the researcher to understand, if I put this data together and use this algorithm for this language combination, how good is this engine? And it uses a human gold test set to measure against. So it says, okay, this is what a human would do. How well did my engine do? And it's, for the developer, quite useful, but not so useful for someone trying to say, is that engine better than this engine? Because there are many other factors that need to be weighed. And so Blue is a very misleading often and misunderstood and almost always measure of how to evaluate machine translation engines. It actually only measures text string similarity. It doesn't really measure quality. So we need to understand that very clearly, that it takes empty output and it looks at the human reference set and then says, okay, these words are in the human reference set and in the machine translation output, so you get a good score for that. But as we know, translations there can be many varieties of translations. So here's basically what it does. You have the human translation and the machine translation, and it looks for common words. The more common words, the longer the phrases that match, the higher your score. And it's, the numbers are usually on a scale from 0 to 1. Many people multiply by 100 to give you a percentage-like equivalent, but very misleading, because an English to French engine, depending on what you use to test, what you use to build the engines, can vary dramatically from 20 to 90. So there is no absolute meaning to that number. So we need to understand that clearly first. The reason it was used, that when statistical machine translation first came out, was people found that Blue often does predict human judgments, that when you get a good Blue score, there's a good probability that the human judgment and the Blue score are correlated. So, so this is old research, but as neural machine translation has begun to proliferate, we're seeing that the choices that neural machine engines make are often different from the reference test sets. And so they score very poorly, even though they're very good systems and much better than others that have higher scores. So, for example, just to illustrate this point, here's a Chinese sentence, and you can see that it can be translated in many different ways. In this example, this is a popular example used among the NLP community to show that you could do it 10 different ways at least. And these are 10 competent ways of doing this, 10 incompetent ways of doing it, and probably 100 really bad ways of doing it. And these are often the sentences that go into your test set. And so you get very misleading results when you use bad test sets. But the problem is that if you use different words, you're not going to get a good score. So for example, in this particular sentence here, you see that this sentence is the closest to what we're using as our human reference. So it's going to tend to score much higher than others that may be just as good. The next sentence may be a little bit clearer, where you see that several of the sentences are really quite adequate translations for the original French. And only one's going to get a very high Blue score, and like this one, which is essentially semantically the same thing, gets a very low Blue score just because it's used different words. And in neural machine translation in particular, there is much more variance in the kinds of words you might use, that you might produce from the engine. And so one of the problems that you have with Blue is that many accurate and correct translations score lower simply because they're using different words. Blue scores are meaningful when they're done by people who have some expertise, who understand the test protocol, that to make sure that you're not testing on data that you've trained with. So what typically happens with the machine translation engine is that you show it a lot of translation memory and you build an engine looking for the patterns in that translation memory. And then you hold a set of data on the side that the engine has not seen. It has to be blind. And then you test it on that. And it needs to be related to the kind of purpose you have, the kind of business objective in mind. And then in that kind of a setting, it can be useful. But many people have, test data that has been seen before, which means it's the equivalent of you going into a student going into a college exam with the answer sheet in front of him. So it wouldn't be much of a test. It would give you very false results because he'll score high because he's got the answer sheet right in front of him. And this is a lot of the public test sets you see, a lot of the claims made by different consultants about this engine is better than that engine because the score is higher than this engine, often forget the fact that some engines have seen the data. So yes, they're going to score higher, but as soon as you bring truly new data to the system, its performance is going to be very different. So the protocol issue is an important thing, and in the language industry in particular, many LSPs who work with machine translation systems don't understand how to do this properly. So the most common problems you see are that they're using the wrong domains. So there's a popular evaluation done that many buyers use today, which is based on publicly available news domain data. That's going to be quite different from what most enterprises are translating. Most enterprises are translating stuff related to their products, to communications with customers, to communications between groups that work in different parts of the company across the world, and with subject matter that is dramatically different from news domains. So using results from these public tests is going to give you a kind of a biased or an incorrect example of what is really possible with your own experience. And so many people are surprised by the results they get when they start using their data or their actual content and see that, well, why isn't it matching what we saw on the test results? Because the data is different. Often the test sets are too small, so they're not meaningful. The worst one is that the data is not blind. There is bias. Many people claim that translators who are translating the test sets, which you're using to measure the systems, are using Google Translate. So Google Translate is going to do better on these tests because they use the same words. So these are some of the issues that you have. There are attempts to look for other kinds of measures. There's no automatic measures that are really foolproof, that are really reliable. The few that are the most popular is an F measure. They're all natural language processing calculations of precision and recall. And they use different formula. They have merits, they have good things and bad things about them, and you need to understand them by looking at how they work across many different kinds of examples. So they're not easily clear. They don't give you the perfect answer. And there were two that were more recently shown to have promise, like Meteor and Leapor, and these as well have not really gained momentum because they don't really give you that much more insight into is the quality going to be. consistently good based on the score. Is the score a good predictor of what's going to happen? And so there is a challenge in the machine translation community at large on how do we really measure how these systems are doing. And there is a need in the enterprise community, the buyer community, that people I want to see a grade, A plus, A minus, B, C minus, and I just want to understand how good this system is versus that system. And the reality is much more complex. It depends on the data, it depends on how you test, it depends on what you want to do. So there's so many variants, there's so many influences of of what the results will be, that using a score as an absolute indicator of quality is generally not going to be wise. So it sounds like I'm bashing on Blue, and it is the most widely used score. Even our new adaptable language pairs give you a Blue score because it's useful for the person building the engine. So it provides a quick and dirty, and the word dirty should be emphasized, quality feedback on how an engine is improving as you feed it more data, as you make modifications to the algorithms, to the data, to some of the process to see if it improves the engine or not. But users need to understand basically how it works. They need to understand what its flaws are, and I pointed out some of them. So if you have an understanding of these, it can be useful to you. But it's really not very useful, even to compare three totally different French systems, for example, because they can have very different results based on what data was used and what data you're testing on. So it's important to understand how these systems can add value and how they're really not good for comparing systems against each other. So we believe that the MT quality discussion needs to evolve. It needs to evolve beyond looking at linguistic perfection. It needs to evolve beyond asking people, what is your Blue score, what is your LEAPOR score? Who scored the highest on that test, on something that you had no real visibility on. And even to basically say that the only translation that's useful or acceptable is one that is exactly what a human translator would do. And we think there's much more value in moving the focus away to what is the impact on business value, and does it help in making more content multilingual and accelerating our digital interactions. So for example, if, like the Texas Instrument example, where they're seeing 3 gigabytes of data being dumped into Google Translate and other public portals on a daily basis. These are about customer interactions. These are about product failures. These are about product design initiatives. They should not be done there. So one of the reasons they chose to use SDL was to keep this within the corporation, to enable communication and collaboration, embed it much more tightly into their communication platforms, and make it possible for employees to share, to communicate with language without being a barrier. So the speed at which you're able to handle customer support issues, that is a better measure than is the linguistic quality better than that other system. And again, many times it goes beyond what happens just in the MT system. In localization, where many of the people are using MT today in the standard business translation world, there the tendency is to focus on, was the productivity improved by using the MT system? Is post-editing MT going to give us the same quality at a lower price, faster? And so, these are the ways that in e-commerce, people like Alibaba who translate 200 billion words a day, their measure is not how good the linguistic quality was. They do care, but their measure is how many people bought products based on the sometimes pretty crappy translation that we gave them. And if that number is meaningful, if it's positive, then they have accomplished the business purpose. And so these kinds of issues are very important to really bring into the picture, and to have the right balance of like what matters when we do this. So and another thing to understand is that MT quality evolves. Most systems can get better if you do the right things. Right things often means giving it feedback, improving spelling terminology errors in the source, adding terminology knowledge to the data that the system understands, targeting corrections of errors that systems are making, and just generally providing human feedback. So as you do more and more of this, you will see that you will have more green section. And that's the objective. You're never going to, I doubt in my lifetime that we're going to see a completely green box. Even though there are some, you can take a limited set of 100 sentences and you can show that to human beings and say that, okay, is this a computer or is this a human? And many times humans, expert humans, will not be able to tell the difference. We've reached that stage today. But when you do 100,000 sentences or you do 1,000,000 sentences, you're going to find some of the black part. And you should expect that. So then you focus on reducing that black part over time. So here's an actual use case that presented by Microsoft at a conference. And they have the same linguistic assessment rules on all these languages. And what they're translating hundreds of millions of words in the knowledge base. The measure of success was the information relevant? Because it's customer support, knowledge-based data. And did this information solve your problem? And you can see it varies. So you can see that just English alone, 60% of the time can solve the problem, and 40% of the time will not solve the problem. But then you'll see that in some, even though they all start with the same linguistic assessment where they say that, okay, this is good enough to go into the knowledge base. And that's done by human language assessment process. And they have the same basic procedure for all the languages. You find that some languages have a higher tolerance for machine translation, and some have very little tolerance, like Japanese, for example. And they have very little tolerance for any kind of support content in general, even the fully human translated content. So you will see that what really they care about in the end was this information relevant, and did this information solve your problem? Because the point of translating 500 million words, and with new words coming in every day, is to solve that, to answer just those two questions. The higher the percentage on that, the higher the success rate, the more successful the whole process is. And this slide shows that linguistic quality is not the criteria that makes the difference here. So, when we look at different kinds of uses for machine translation, we'll see that in different use cases, there are different things that matter. So for customer service and support, more successful self-service is a very good indicator of success. Rapid access to all the new technical information that comes out is an indicator of success because more people will have access. And often these lead to improved customer satisfaction, a smoother customer journey, and other things that matter much more. So when we look at localization, the primary motivator is faster turnaround. Machine translation, when done right, when done with competence and expertise, can provide faster turnaround. It can give you a lower cost production, a better machine editing, post-editing experience, and some engines, like the ones at SDL, are being designed to have much more interactive engagement with translators. So they improve faster. So they improve in the ways that you care most. But if you're looking for the highest return on investment, what you will find is that localization is probably not the best place because they have low volumes and the quality expectations are very high. So it's not the best place to get high ROI on machine translation. You will get much better machine ROI on customer support, on communication and collaboration in a global enterprise, on social media analysis, because customers are telling you what they think about your company, about the brand every day now. Knowledge-based content, just making large volumes, millions, hundreds of millions of words, multilingual. That is where you will get the greatest benefit from machine translation use in the enterprise. And more companies are beginning to realize this. And remember, I showed you that first slide. 1 trillion words a day and many, huge volumes of rogue enterprise use because they don't have other means to solve these things. So what is important to understand is how do MT engines improve? Because using scores to make a selection of an MT engine is not the best and most informed way to proceed. It's important to understand, how do MT engines improve? First is the core technology. We have seen that as we move from rule-based to SMT to neural, there have been continuing improvements. At SDL, we're seeing that just in our second and third generation neural systems are significantly better than the previous one. So the neural benefits are still evolving. Always better and more data. So right terminology data, the more translation memory that is clean, that is properly optimized, primed, and is relevant to what you want to translate. Not just any old random stuff that you happen to find in a closet somewhere, but stuff that is related to what you want to translate. The more overlap there is, the better your results will be. Process innovation. Sometimes the best results can come from a very smooth interaction between how the machine translation engine is prepared to how it is post-edited or to how it is used in the field and how you decide on the optimization process. And so that's another source. Source analysis, another area where if the source is clean, the results are going to always be better. And if you apply some effort on fixing the source before you go in, you will find that as well. And learning to gather human feedback. So as you begin to gather human feedback, you'll find the big patterns. You'll find the things that humans find most offensive about the MT translations, and you will focus your effort, 90% of your effort on the 10% of the things that really matter to people. So you know that the certain things can't be wrong. In medical or pharmaceutical things, when you say that you need to take this drug, it should be related and it should be accurate, because if you tell someone not to take a medicine and they could die, the consequences can be very severe. So you have to match and bring the human feedback in where it really matters. And so this, and working with a vendor who understands this, is a very key thing. So if we look at the MT output reality, it's a very dynamic, evolving flux. It's constantly changing. At SDL, we have production systems that are already out there that everybody is using. But there's research going on a daily, weekly, monthly basis that is modifying and updating these engines all the time. There's already dramatic improvements we've seen from the engines that are already out there, and then there's a process to make sure that the new learning is implemented in a robust, scalable, and enterprise-friendly way. So it's a mixture of all these kinds of things. And again, it's important to optimize around the useful to the business purpose, rather than linguistic quality. That's the mindset that you need to change. So when you're dealing with real MT problems like millions of words rather than thousands or tens of thousands of words, post-editing is often not really a possibility. At the knowledge base application, 500 million words, cannot be post-edited. It's not physically possible. So you can post-edit that which is most important, stuff related to stuff related to security, or stuff related to very critical information management needs. In a hotel scenario, for example, you would post-edit the 5-star and the luxury hotels, but you would not post-edit the 1, 2, and 3-star hotels. So it's a way, you have to apply this information triage knowledge process on. It is worthwhile to translate hundreds of millions of words, but you have to apply and do it intelligently so that your efforts focus on where it matters. And this is something that SDL has expertise and experience with. So when we look at the kinds of places where MT quality is an issue, we see that in legal, marketing, and localization scenarios, the target quality is very high. And for it to be useful, and it needs to be very tightly integrated with feedback mechanisms and post-editing software. And this is what we're trying to do. But in knowledge-based customer experience content and just communications and collaboration, the volumes are huge and the quality requirements are much less. I'm going to hand over to Pete, who will describe some things that he's done to focus on different ways of measuring the quality of MT systems.
Well, thank you, Curdy. Hopefully I'm audible in the back there. One of the things we have been doing over the past several years at University of Texas is engaging in these conversations with Curdy, who through webinars and other means has really started our local campus students as well as researchers thinking about some of the questions he just raised. How can we think about MT in ways that are richer, a little less dependent on a single automatic score, automatically generated score? How can we use some of the best practices in natural language processing to advance our thinking about quality and advance really our understanding of the data we're working with? And you'll notice from the title that we've been particularly interested in customer experience, customer collaboration data. And I've called this problematic data, and we're going to share some examples with you in a few moments that may in fact be your engines are very poorly prepared for this sort of data and these sort of translation challenges if they've trained on legal and technical and the more standard news variety. The current research project that we're involved in, and I wanted to note Henry Anderson, the young data scientist who helps us in this process, really takes some of the focuses that Curdy asked about. How do we develop quality testing? How do we deal with issues such as domain, test set selection, some of those key elements that we oftentimes miss? And right in the hot spot of that chart, enterprise collaboration, customer feedback, customer communications is where we have focused. Just very quickly, the work that we do at the university is based not at the doctoral level, but primarily with undergraduate students and master's students. And one of the things that students at University of Texas in Arlington do is build MT engines and think about the issues. How do I evaluate output? What sorts of data do I feed that engine to train it? What are the critical elements like domain or test size or some of the other elements that he mentioned? For those of you who are not familiar with my organization at the University of Texas, we have one very large campus in Austin that many people are aware of. I'm actually at the second campus in the Dallas-Fort Worth area where these students are doing localization training. The dark secret is we're actually bigger than the campus to the south. So we're not the flagship campus, but we are the largest campus in the system. We started thinking about quality, we started thinking about test sets, and the research project began as a test set creation project. Could we take and develop a training, if you will, a test set that did not look like the test sets that are primarily used in news, current events, governmental, parliamentary, blue scoring sorts of procedures. And we were terribly interested in what enterprise users had to say. What are the words that enterprise users say to you? What are your customers saying to you? What sorts of language do they use? And what are all the paralinguistic features about that language? You want to know when a customer is angry. An angry customer or a sad customer is not something you are striving for. When a customer is deliriously happy, you want to know that. So we began to explore that locus of issues using NLP standard procedures that might be used to build, for example, much of the SDL set of software comes from NLP, and we wanted to apply some of those emerging techniques to this test set. We gathered several million sentences of customer words, customer utterances. What is it that customers were saying to the businesses that they were interacting with? We selected from email, from customer communications, from help desk, online customer support, and then went through a modeling procedure where we basically splayed all of those utterances, several million of them, into both a linguistic process and a semantic process. Standard NLP would have us thinking about the quality of stop words, vocabulary, number of emojis, and a variety of other sorts of pre-processing elements. But we also then splayed those utterances into a semantic space in an attempt to build a test set that was truly representative of the million sentences or million plus sentences that we had. We couldn't have a test set with 3 million sentences. We actually found about 1,000 that we used for this test set, reduced the dimensionality, did some clustering, and said, do we have a test set that will let us better understand, perhaps even better score machine translation of these very challenging, very specific sorts of language? One of the first rules of data analytics, and I come at it both as a language faculty member, but I also serve as the chief analytics officer for our university. The number one rule is know your data. We all think about the tools. We all think about the models. We rush to do the most in the most multidimensional space with billions of parameters. And oftentimes the mistake we make is we don't spend time with our data. So here are some of the utterances that we encountered in our process. What do you do? How do you translate a phrase from a customer like, you support people, I effing hate you? Obviously, not only are there linguistic challenges and semantic challenges, but there's issues of tone and a variety of other elements going on here. Those late in the day deliveries go missing a lot. How do you deal with sarcasm? How do you deal with the very rich and varied things that customers say? Seriously, this is not okay. Using a dictionary-based approach to that string, you may actually begin to think of it as more positive than negative. But if you leave with one translation challenge or one translation thought from the conference this time, how might you or your linguists or the software that you have at hand deal with this? Hashtag, how do you stay in business? A single element, a single n-gram. Blue would fail us terribly at this as we try to score it, but these are the sorts of challenges that we have. And one of the things that popped out to us very quickly was this notion of tone. Could we, as part of the machine translation process, be more sensitive to, perhaps even train engines or tools to take into account customer tone? When I'm angry, is that conveyed appropriately in the translation? When I'm happy, is that conveyed appropriately in the translation? So when I get a customer utterance like all caps, no one is telling us anything, that carries a variety of linguistic and semantic and syntactic meanings that we need to bring into account. One of the first things that we did was use a fairly standard tool out there called Vader, a Python library that speaks about the valence, right, the positive or negative and strengths of the positive or negativeness in these particular utterances. But one of the things we found out, and the hypothesis would be, If blue, for example, is a measure of any value of translation quality beyond n grams or string matching, and I think you've probably understood from our conversations that we don't think it's much beyond that, it would probably be affected by tone. We would expect that translations that were extremely challenging because of tone would also be extremely challenging both to translate and score. And unfortunately, what we found out is most of the common measures are just not simply that good. Even Vader, a tool that knows what to do with all caps and knows what to do with emojis and knows what to do with things like your spelled UR, honestly didn't really find things like support I effing hate you all to be that negative. And it found some other things, looks good so far, which to me sounds like rather a generic positive sentence, to be one of the most positive things it said, probably because there was a little smiley emoji after it in the customer utterance. So in the end, we also made use of the IBM Tones analyzer. Many of you may also be thinking about these other major tools that are out there for getting customer tone. It was a little better at finding the support utterance to be angry, but sentences like your support is insensitive, all caps, and unjustified. In fact, the IBM Tone Analyzer said, nope, not angry, not sad, not fearful at all. So not only do sometimes our machine translation engines fail us in output, so do some of the larger NLP tools at all. What came out of this? What was our end game here? It's an ongoing process. We're bringing human evaluations in because obviously humans are going to be able to deal with that paralinguistic and affective sort of tone or style, things such as sarcasm or use of hashtags, for example, in much more sophisticated ways. And honestly, we were finding that blue was even less helpful to us in these situations of high emotive content than anything else. All of you have customers. All of you have customers talking to you every day, talking to your support divisions every day, have customers that are saying things like this. And if you are trying to think about MT as a way to deal with them, what this research will probably show you is, in its current state, it is not going to be very helpful to you at all. Context matters, domain matters, and measures like blue, unfortunately, really do not give us insight into our data. So as you look into data and as you look into what I've called these more problematic sorts of content, but content that's extremely valuable to us, it's in that hotspot of customer support, customer experience, we have a long way to go in thinking about how our MT engines and our MT tools are really going to help us score these utterances, think about these utterances in richer and more dynamic ways, and really let us think about these utterances across languages and cultures. And with that, I'm going to hand it back to Curdy. We just have about 2 minutes left.
So I'm just going to end quickly with the SDL MT solutions address many of the key issues that enterprise customers have, especially around control of data security and manageable efforts and strategies to improve the quality, and as well as deep integration into, connection into all the key architecture that you have to keep your data flowing around the company. There's various levels of engagement when you customize engines. There can be things that you can do, there are things that our experts will help you do, and there are things that we can bring linguistic expertise in as well. So there's a broad range end-to-end solutions that we can provide here. The adaptation of MT engines can vary with and require different levels of effort. The more effort you put in, the more likely, if you know what you're doing, the better the systems will be. There are some things you can do, and there's some things that we will help you do. And really, the quality that matters is in the business ROI.